The aim of every well rehabilitation is to restore the original functionality by removing mineral and organic deposits from the inner surface of the pipes, screen slots, external surface of the screen, as well as from the gravel pack and the adjacent geological formation. W130, the technical bulletin of the German Gas and Water Association, defines a state-of-the-art rehabilitation, including 3 working steps, namely separation of deposits from all surface areas. Secondly, the removal of these loosened deposits from the well. And thirdly, the control of the entire rehabilitation process by step discharge test in the first place, here with the results before and after the rehabilitation of KS9, one of the wells surrounding the Parliament buildings in Berlin. Additionally, the control can also take place by regular measurements of the electrical conductivity and pH value, as well as iron and sulfide concentrations, as documented also in KS9. A CCTV camera inspection is another standard control instrument between different phases of the rehabilitation procedure. Here showing KS1, also one of the Berlin wells. Geophysical inspections, like here a focused gamma log of KS3, deliver an ultimate proof of the efficiency of the applied measures. Even the dissolved and removed quantities of deposits can be easily quantified by mass balancing. Here in KS9, a total of 1.5 kilo dissolved iron by applying 150 kilo of the pH neutral extractor 2, and in KS1 a total of half a kilo by 75 kilo of the same agent. Mechanical cleaning by brushing or jetting is successful as long as deposits are soft and of low crystallinity, as the heaviest clogging adheres next to the screen. Often, the structural condition of the well interior can only be inspected in detail by CCTV after the mechanical cleaning in order to determine the further rehab strategy. As for the physical penetration depth of different rehabilitation techniques, Groundwater Research Center Dresden examined them 20 years ago already, including strainer pumps, low pressure flushing units, different high pressure rotation aggregates, impulse generators, ultrasound transmitters and gravel washers. The results, which are still valid, confirmed that the efficiency of the rehabilitation devices, which extend washing processes beyond the screen, depends proportionally on the velocity of the circulation, and that the larger the circulated water volume is, the more efficient is the technical device, and finally, that multi-chamber devices, the so-called gravel washers, are the only technique which reaches not only the gravel pack, but also the annular space. Thus, the best results are achieved by low pressure and high circulation volume, which carry out washing processes beyond the screen. We call them simply gravel washers. They match the characteristics of the well to be treated as per diameter, length of chambers, circulation capacity, and the pump type. Most sophisticated pieces of equipment enable the simultaneous separation and removal of deposits by a built-in pump. Additionally, a bypass from one of the chambers enables a continuous control of the entire process. The execution of all 3 working steps without any interruption helps to save costs. The advantage of a chemical rehabilitation becomes apparent when quantifying the additional achievable yield increase. Here we have an example of a gallery of 37 production wells near Dresden, with a comparison of working hours, yield increase and total cost between a purely hydraulic method without a chemical treatment in yellow and a combined hydraulic chemical rehabilitation in blue, documented by the client. As we can see, the required time for both measures is identical, but the yield increase by the chemical rehabilitation is almost the double. And the last but not least, the cost of the chemical rehabilitation represents only 27% of the cost of the hydraulic method. This means that the client was able to save more than 70% of his budget. When removing iron and manganese oxides, we notice remarkable differences of dissolution capacity and reaction velocity between pH neutral and pH controlled agents. The pH neutral reaction in blue is completed in 45 minutes, whereas hydrochloric acid with pH 1 in red requires 12 hours. The dissolution capacity of pH neutral agents is 50 times greater than that of hydrochloric acid in identical molar concentration. That means 100 gram dissolved iron 2 compared to 2 gram. The success and the time interval between two rehabilitations depends, of course, on the structural condition of the well, the mode of operation and the switching rhythm, as well as on the hydrochemical raw water quality and the flow rate over time. Primarily though, it is influenced by the point of time of the execution and the thoroughness and effectiveness of previous rehabilitations. Chemical treatments increase the well performance decisively, sometimes even exceeding the original yield at commissioning.